Hello everyone, welcome to Unacademy. Let's crack it. Today's session, complex variables part 2. In the previous video, so we have discussed the complex variables concepts and a few formulas and a few tricks to crack the basic questions. Today it's continuation of the complex variable. Yes, before moving to the complex variable topic, I will explain the compact details to you. So you can attend the compact, then you can get some benefit through the compact test. Every week, India's largest weekly competition for GATE and ESE, 4th July, 11th July already over. And coming Sunday, 18th July, you are going to get the next compact. Mechanical, Civil, Electrical, Electronics, Computer Science and IT. Take it live to compete with the best. Access your GATE preparation within the 60 minutes. And use the code Moorthy536 to unlock your compact invite code. Now the Unacademy compact, complete, crack and conquer, and if you secure the rank from 1 to 3, you can avail the complimentary Unacademy Plus subscription for GATE and ESE 1 year. And if you secure the rank from 4 to 10, 75% offer on the Unacademy Plus subscription for a teacher of your choice from 6 months, 12 months, 18 months, 24 months. GATE and ESE subscription. 11 to 50, 50% offer. Rank 51 to 100, 25% offer on the Unacademy Plus subscription. Right? So these are the benefits available. So you can get some discounted price for the GATE and ESE subscription by cracking the compact. Laksha for GATE and ESE 2022. Arohan for GATE and ESE 2023. Right, before price hike, so you can take the subscription to beat the price hike. Mechanical engineering batch E complete course. We are starting with the metal cutting by Rajiv Singh sir, and it's 6:15 p.m. July 14th already we have started, right, yesterday itself. If you're interested, you can join into the batch to get the benefits. Spark for GATE 2022 and Wave for GATE 2023. Complete batch course, English batches, batch B. Praveen Kulkarni sir, Devendra Singh Negi sir, Vivekanandan, myself. We 4 together handling complete course for the mechanical engineering. Use the invite code Moorthy536 to join into the batch. Okay, fine. Now the complex variable continuation and the engineering mathematics complex variable. Yesterday we have discussed formulas as well as properties, modulus and conjugate properties as well as for the argument of the complex variables. Now the multiple choice questions, previous year multiple choice questions from the complex variables today. For this question, identify the moduli as well as principle of complex number. The principle of complex number, it indicates that it's an argument. Argument is called as principle. It's an argument. It's an argument is called as principle of the complex number. Now modulus we need to do. So before doing the modulus, first simplify the equation. It's 1 plus 2y divided by 1. It's 1 square plus I square is equal to minus 1, right, and divided by, sorry, minus 2xi minus 1 into I, it's equal to 1 plus 2y divided by, again it's 1 plus 2y, it's completely is equal to 1. And if you take the modulus, so what about the modulus? Moduli 1 is equal to, it's equal to 1 plus I into 0. It's equal to modulus of 1 plus I into 0 is equal to root of 1 square plus 0 square. So root of 1 is equal to 1. Then argument for the given complex number. Argument, it's theta is equal to tan inverse of it's y divided by x. Now compare this equation with x plus iy. Plus I1. Therefore here x is equal to 1, y is equal to 0. And if you substitute the x is equal to 1 and y is equal to 0 in this equation, it's equal to tan inverse of It's a 0 divided by 1. 0 divided by 1 is equal to, what will be the value for this question? 0 divided by 1. It's 0. Now moduli 1, its principal 0, 1 comma 0. It's option C is the right solution for this question. Next one. Now the complex conjugate. If z is equal to x plus iy means conjugate of z, it's equal to z bar. It's equal to z bar is equal to x minus iy. Likewise, first z. Now we have to do the simplification process here. It's 6 plus 5y. Now do the rationalization function here. Actually the denominator all are real numbers, right? All the real integers. So we are going to take the real integers directly. It's 2 minus I. Now multiply by, it's 2 plus I. Here it's 2 plus I. And if you multiply the value, it's 2 in 12 plus 10i. Then it's plus 6i minus, plus 5i square divided by, it's 2 square minus I square. It's equal to 2 square minus I square. 12 plus 16i minus 5 divided by 4 plus 1. It's equal to 7 plus 16i divided by 5. It's an z, right? Now the z conjugate is equal to z conjugate. We need to change the sign of the imaginary part. Then 7 minus 16i divided by 5 is equal to 7 divided by 5 minus 16i divided by 5. Conjugate means, so we need to change the sign of the imaginary part. It's A. A is the right option for this question. Okay. Next one. The one more very important question. It's mechanical engineering 2016 question. Sorry, 2006 2-mark question. Now, assuming I is equal to root of minus 1 and t is a real number, then we need to identify this value. So directly we can do. So e power it is equal to, now substitute the exponential form of the complex number will be written in the form of trigonometric equation. It's cos t plus I sin t. So it's a process, right? Now substitute this value instead of this integration. While substituting it, what we are getting here, listen, it's integral of 0 to pi divided by 3 cos t plus I sin t into dt. While integrating it, what we are getting, cos t integration equal to sin t plus sin t integration minus cos t minus I into cos t. Now substitute upper limit pi by 3, lower limit 0. And while substituting the upper and lower limit, it's equal to integral of 0 to pi divided by 3 e power it into dt. It's equal to it into dt. It's equal to sin t minus I into cos t. It's pi divided by 3. Here it's 0. Now substitute the pi divided by 3. Sin pi by 3 minus I into cos pi by 3 minus its upper limit minus lower limit. Sin 0 minus I into cos 0. So we need to take the value of the sin pi by 3 and as well as for the cos pi by 3. What about the sin 60? Sin pi by 3 is equal to, it's root 3 divided by 2 minus I into cos pi by 3 is equal to 1 divided by 2 minus sin 0 0, it's plus I, cos 0 is equal to, it's 1. Now what about the value? It's root 3 divided by 2 minus I divided by 2 plus I. So it's a plus I divided by 2. So this will be the final answer. 3 root of 3 divided by 2 plus I divided by 2. It's option A. Option A is the right answer. Next one. Now the modulus of the complex number. It's 2010 1 mark question, mechanical engineering question. Now we are going to discuss all the mechanical questions. It's mechanical engineering 2000. Now we need to take the modulus. We know the modulus means after doing some rationalization, so we need to substitute. If z is equal to x plus iy, what about the modulus? Modulus of z is equal to root of x square plus y square. Now we are going to use the property. Modulus of z1 divided by z2, it's equal to, as per the modulus property, modulus of z1 divided by modulus of z2. The same property we are applying here. It's 3 plus 4i divided by 1 minus 2i modulus. It's equal to modulus of 3 plus 4i divided by modulus of 1 minus 2i. So these are all the two conditions, right? Now apply the same modulus. It's root of 3 square plus 4 square divided by, it's root of 1 square plus minus to the whole square. What will be the value? It's root of 3 square plus 4 square is equal to, it's 25 divided by root of 5. It's a 5 divided by root 5, it's equal to root 5. Now root 5 is the solution. It's option B. Your option B is the right solution for this question. Is it clear now? Next one. Now the product of two complex numbers, and what will be the, it's a simple one. Directly we need to multiply. Now I is equal to root of minus 1. I square is equal to, it's minus 1. It's a condition in the complex number. Now by using this product, 1 plus I into 2 minus I, it's equal to, now multiply 2 plus 2i minus 5i minus 5i square. Now substitute the value. It's 2 minus 3i minus 5 into I square is equal to minus 1. It's equal to 7 minus 3i. 2 plus 5 is equal to 7 minus 3i. It's A. Option A is the right answer. 7 minus 3i. It's GATE 2011 question, right? So let us, if you are having any doubt, immediately ping your doubt in the chat box in the live class, right? In the forthcoming months, in the now next 2 days, tomorrow and after tomorrow, next 2 sessions, complex variables part 3 and part 4, we are going to complete the Cauchy-Riemann equation, CR equation. It's very important part in the complex variable. Today we are going to complete the basics of the complex with multiple choice questions. Now the argument of the complex number. So what will be the argument of the complex number? We know the argument. So what about the, if z is equal to, it's a formula. First I am writing the formula followed by the solution. If z is equal to x plus iy, argument, it's theta is equal to tan inverse of y divided by x. If it is two numbers, z1 divided by z2, here it's argument. Here argument, it's theta is equal to tan inverse of y1 divided by x1 minus tan inverse of y2 divided by x2. Is it right? So now we are going to apply the given data from the argument of complex number. It's 1 plus I divided by 1 minus I, where I is equal to root of minus 1. So what will be the answer here? Now substitute tan inverse of, what about the x? It's equal to x1 plus I into y1. It belongs to the x2 plus I into y2. Now y1 divided by x1, it's 1 divided by 1. Is it clear now? Minus tan inverse of, it's minus 1 divided by 1. Now tan 1 is equal, tan inverse of 1 is equal to, it's pi by 2, minus tan inverse of minus 1 is equal to, it's minus pi by 2. And if you apply the value, and what about the value? It's equal to pi by 2 plus pi by 2, it's equal to pi. It's equal to pi. It's option D is the right answer for this question. Okay, it's an argument of the complex number. Next one. Given two complex numbers, z1 is equal to 5 plus 5 into root 3 I vector, and z2 is equal to 2 divided by root 3 plus 2i. The argument of z1 plus z2 in degrees. So we need to calculate in terms of degrees. The same formula argument for the z1 divided by z2. So formula for the argument as like the previous question. It's equal to, we need to calculate the value of tan inverse of, it's theta. It's theta is equal to tan inverse of y1 divided by x1 minus tan inverse of y2 divided by x2. Now the given number z1 is equal to x1 plus I into y1. It's equal to 5 plus 5 into root 3 I, and from this equation x1 is equal to 5, y1 is equal to 5 into root 3. And coming to the z2, here z2 is equal to x2 plus I into y2. It's equal to 2 divided by root 3 plus 2i. What about the value of x2? x2 is equal to 2 divided by root 3, and y2 is equal to x2. Now the argument in terms of degree we need to substitute. Now give the value for the argument. Now it's theta is equal to tan inverse of y1 divided by x1. y1 is equal to 5 divided by root 3, sorry 5 root 3 divided by 5 minus tan inverse of y2 2 divided by 2 into root 3. Now the 2 cancel, 5 cancel, and what about the value here? It's equal to tan inverse of root 3 minus tan inverse of root 3. Therefore theta is equal to 0. Now in terms of degree, the argument for the two complex numbers, given complex number, is 0. It's A. Is it clear now? It's 2015 Mechanical Engineering set 1 question. Okay, next one. I'm giving the next question. Listen. Now z is equal to 2 minus 3a divided by minus 5 plus I can be expressed as. So here we need to do the rationalization. It's a single line equation, so we need to convert the denominator into the real number by doing the rationalization. So now I am giving the z. Here z is equal to 2 minus 3i divided by minus I plus I. Now multiplying the both numerator and denominator, it's minus I plus I, minus 5 plus it's minus, right? Actually minus 5, it's minus, both side minus, minus 5 minus I, minus 5 minus I, and if you multiply, it's minus 10 plus 15i, minus of minus, it's a plus 3i square. Is it right? Right. Here it's minus 10 and it's plus 15 3i. Now minus 2i, I into 2 is equal to minus 2i, then it's minus of minus, and what will be the value here? It's minus of minus, it's plus 3i square divided by a minus b the whole square format. So we need to do the a minus, so a square minus a minus b into a plus b. It's whole divided by minus 5 the whole square minus I the whole square. Now do the simplification here. Minus 10 plus 13i minus 3. It's a whole divided by 25. It's plus 1. 25 plus 1. So we can write the value minus 13 plus 13i divided by 26. Minus 13 divided by 26 plus 13 divided by 26 into I. It's 1 divided by 2. Minus 0.5 plus 0.5 I, and here solution is equal to it. It's B, right? Here B is the right solution. Okay, the next one. Now the real part of the complex number is that is equal to. What about the real part of the complex number is that? That is equal to x plus iy. So we are getting the value that is equal to, it's x plus iy is given by, and what about the real part? They are giving it's z star. It indicates that z star indicates that it's conjugate. Here z star is equal to x minus iy. X minus iy. And what about the real part? And how we are getting? First we are going to start plus addition. Then we are doing the multiplication. First addition followed by multiplication. And how we are getting the solution? First we will check it. Z plus z conjugate, it's equal to x plus iy plus x minus iy. Is it okay? It's equal to plus iy minus iy cancel, it's 2x. Here x is the real part of z, so 2 into x is called as real part of z. Therefore real part of z is equal to z plus z star, that is z conjugate, divided by 2. Is it clear now? Yes, solution for this question it's option C. And option C is the right solution for the question. Next one. Now cos pi can be represented as, so how we are representing the cos pi? Actually exponential terms, we need to check from the exponential terms. E power I pi is equal to, it's a cos pi plus I sin pi. I sin pi. Now next one, e power minus I pi, it's equal to cos pi minus I sin pi. And if you want the value, what we need to do here? And if you want the cos pi value, so we need to add the equations, two equations. And if we subtract, the cos pi value will be eliminated. Now take the value e power I pi plus e power minus I pi is equal to, it's cos pi plus I into sin pi plus cos pi minus I into sin pi, and here it's a plus minus cancel, it's equal to 2 into cos pi. Now what about the value of cos pi? Cos pi is equal to e power I pi plus e power minus I pi, it's a whole divided by 2. E power I pi plus e power minus I pi, it's plus, not the minus, it's plus. And solution for this question here, it's D. Here D is the right solution for the question. Is it right now? Now the next question to you. Now let j is equal to root of minus 1. Then one value, yes, then one value of j power j is. So what will be the solution here? Parallelly you try this question, and here I am giving the solution. You try to crack this question. J is equal to root of minus 1. So how to correlate? J, first option, minus 1, j square is equal to minus 1. We can't take j power j. The only thing we can do through the exponential equation here. Through the exponential equation we can write the value easily. We know that e power j into pi by 2 is equal to, so we can write it's cos pi by 2 plus I sin pi by 2, right? Ij sin pi by 2. Yes or no? It's equal to j, e power j. E power j into pi by 2. J into pi by 2 is equal to cos pi by 2 plus j into sin pi by 2. So cos pi by 2 0, and sin pi by 2 is equal to 1, it's equal to j, right? And what will be the value of j power j? Here they are asking j power j, e power j into pi by 2, we are aware of it, it's j. Now power j, now it's e power j square into pi by 2. What about the j square here? From this equation, it's j square is equal to minus 1. Now substitute j square is equal to minus 1, therefore minus pi by 2. Now the j power j, it belongs to the e power minus pi by 2. It's option D. Is it clear now? It's a simple question. Okay. The next. So these are the basics of the complex variable and the basic multiplication, addition, modulus, conjugate, as well as argument calculation for the complex numbers. It's basic one. We are getting repeated questions in the GATE exam. Next, we are moving to the analytical function. So analytical function, it's very important one. Now I am going to give you the introduction to the analytical function. In the next video, tomorrow at 6 p.m, live class, complex variable part 3, we are going to discuss all the analytical functions, multiple choice questions with tricks. Now coming to the point, the concept of analytical function is the core of the complex analysis. Unlike differentiable functions, analytical functions have many additional properties. In the differentiable functions, only the direct differentiation or ordinary differentiation or partial differentiation. But coming to the analytical function, it involves more additional properties along with the differential equations. A complex function f of z is said to be an analytical at a point z naught. A complex function f of z is said to be an analytical at the point z naught if f of z is differentiable at z naught and at every point of some neighborhood of z, right? The complex function f of z is said to be analytical at the point. So whenever the given point is differentiable in the given region, then the function is called as analytical function. Function is analytical in the domain D if it is analytical at each and every point of the domain D. It's a condition. Now the necessary and sufficient condition for f of z to be analytic. So whenever they are giving some complex function f of z, so what are the conditions need to be satisfied in order to the system must be analytic? When we are saying the system is analytic, there are two conditions are there. The necessary and sufficient conditions for the function f of z is equal to u of x comma y. Here the function depends upon the two variables x and y. U of x comma y plus I into v of x comma y to be analytical in a domain D. To be analytical in the domain D. Dou u divided by dou x comma dou u divided by dou y comma dou v divided by dou x comma dou v divided by dou y are continuous functions of x and y in the domain D, right? So it must be continuous function. It must be continuous means it must be differentiable when it is continuous. Whenever the function is differentiable, then obviously it's a continuous one, right? So dou u divided by dou x, these functions must be continuous while doing the differentiation. Second condition is the very important condition. That condition is called as CR condition. It's condition. Yes. Here dou u divided by dou x. And what is u here? It's a real part of the function is called as u. And imaginary part of the function is called as v. Now dou u divided by dou x, it's equal to dou v divided by dou y. Right? Real part function with respect to x, it must be equal to the imaginary part differentiation with respect to y. Then dou u divided by dou y, it's equal to minus dou v divided by dou x. In short form, differentiation of u with respect to x, ux, it's equal to vy. And here with respect to y differentiation uy is equal to minus vx. The second condition, ux is equal to vy and ux is equal to minus vx are known as Cauchy-Riemann equations. Whenever the given function f of z is analytic, then this condition must satisfy these two properties. first and second step, right? So these are the basics of the analytical function. In the next video we are going to start the remaining parts from its basics along with the multiple choice question, previous year multiple choice question.